If you search YouTube, you can find tons of reviews about the Apple's newly released Mac Studio, but I haven't seen anyone talk about the 10 gigabits RJ45 part in details. I also have a Mac Mini. It doesn't come with 10 gigabit RJ45. It's just the default 1 gigabit. I didn't pay the extra $100 to upgrade, but I do need 10 gigabits parts. So I purchased the OWC adapter, and later I purchased another one for my Intel mini PC. In this video, let me compare the 10 gigabits adapters performance with the Mac Studio's built-in 10 gigabits RJ45. As you know, the most important thing when we talk about a NIC or network controller is about its chip. So let's first check what's the chip used in the Mac Studio and what's the chip in the two external adapters. On the screen in the left side, I'm showing you the system information from macOS. You'll see 3 different devices here. The first one is the built-in native Mac Studio 10 gigabit NIC. The last two are for the two external adapters. Let's look at the first one. Even though the vendor says Apple, but if you check the chip name, it's AQC113. AQC is Accontia. As I know, Accontia was acquired by Marvell in 2019. So in the right side, I searched the Marvell website and I got the specification for AQC113. We will look at that later. Go back to this system information. There are a lot of interesting things going on. First, the bus, it only says PCI. It didn't say the version. But if you look at this one, the PCIe link width is just ×1. So we all know there's no way for PCI 3, if you only use one lane, you can achieve 10 gigabits. So just by reading this information, I'm already sure it is PCIe 4. Then look at the right side from the spec. You can see support line rate up to 16 GT. So just one lane is already exceeding the 10 gigabits, right? But if you check this, the PCIe link speed, it only says 2.5 GT. It doesn't make sense to me because according to the spec, it's 16 GT. It seems Apple has this information wrong. Then let's look at the two external adapters. It doesn't matter it's OWC or CalDigit. They are using the same chip for the network controller. They are both AQC107. In another tab, I do have the AQC107 spec. It says PCIe version is Gen 3, and for one lane it supports 8 GT. It's not enough for 10 gigabits. That's why it works in ×4 fashion. If you check the Apple's system information, you can see the same thing. Each lane, 8 GT, link width is ×4. And in the end, you also get 10 gigabits. Just by checking the system information, we know, okay, even though it's built-in NIC for Mac Studio, it's not really from Apple. It's using the chip from the same vendor as the other two external devices. I do not expect dramatic performance difference. Let's validate it. Now let's take a look at the testing environment. All my devices for this test are located in 3 different rooms. In the center, in the server room, I have a Ubiquiti Unified Aggregation switch. In the client room, I have the 2 Mac machines, and the Mac Studio is directly connected to the Unified Aggregation switch using a Ethernet cable. Mac Mini first connect to the 2 external adapters using Thunderbolt cable, and then the 2 external adapters are connected to the switch using Ethernet cable. Because the switch only supports SFP plus to connect to the RJ45 part, I use the 3 transceiver modules. They won't impact performance. In the server side, I have a Synology NAS connected. In the complete network traffic path, I have 3 different unified 10 gigabits switches. Everything is 10 gigabits from the server room connected to the room 1 and room 2. I use fiber connection. They are also in 10 gigabits. I also make sure all the devices are in the same VLAN to exclude the router as a factor. So in the whole testing, the traffic doesn't go through the router. And the last thing I make sure is in the complete path, every device has the jumbo frame setting enabled. Because there are so many devices, I will only show you within macOS how I enable jumbo frame. This is the network setting for macOS. Let me choose this Ethernet device, which is the Mac Studio built-in 10 gigabits NIC, and select it. In advanced, click hardware. By default, it's automatically. If you switch to manually, under MTU, you can enable jumbo frame, or you can set to custom one. I won't spend too much time on jumbo frame. If you are interested, you can check another video in my channel. In this video, I'm going to test several different things. First, upload speed, then download speed, then download and upload concurrently. Next, I'm going to test the NAS read and write speed. Then I will show you the power consumption comparison, and then the temperature change comparison, and then let's talk about the fan speed change or noise level comparison. First, about network testing. I'm going to use iPerf3 for upload. I'm going to use this command, connect to the NAS machine. In NAS, I already run the iPerf3 server, and here I'm running it in client mode from the Mac machine in a terminal. I'm going to test the speed in 60 seconds, and then the iPerf3 will give me the average speed. This is for upload. To test download, I will specify dash capital letter R means reverse, and to test the download and upload at the same time, I'm going to run this command, specify dash dash by dir. iPerf3 will run the upload and download at the same time. I will skip the boring testing process, directly show you the results. This is iPerf3 network speed testing result. In this area, you can see the meaning of different colors. Let's first check upload and download. First, the download and upload speed are all very close to the 10 gigabits theoretical upper limit. Pretty good results. But if you check the concurrent upload and download, Mac Studio has pretty even but not perfect results for upload and download. CalDigit has the best result, especially the download is even close to the pure download mode. The OWC has a little bit worse upload speed when it comes to concurrent upload and download. For each one of them, I tested multiple times, and to be fair, I didn't pick the average value because I know due to the network condition or different temperature of the devices, it may impact the results, right? So I picked the best results for each of them. This result is already the best I can get. To test the NAS read and write speed, I use disk speed test. Click this button to select the NAS shared drive and start testing. As you know, this is the real world testing. It's not just testing the network speed. It's also determined by how your NAS is configured. For example, how many drives you have, whether it's RAID 5, RAID 6, whether you have write cache or read cache, right? Many factors. But the upper limit is your network speed, which is 10 gigabits. Similarly, I will skip the detailed testing, directly show you the results. As you can see, CalDigit is the fastest one, but all three of them have very similar read speed, almost saturate the bandwidth of the network. But when it comes to write, the Mac Studio is the slowest one. OWC is in the middle, but all three are very good. I believe in real world, if you can get this type of NAS access speed, no matter which one, it's good enough. Now let's talk about the temperature testing. This is a tricky one. For all the three devices, I'm going to test the three different temperatures. First, when the device is inactive. Second, when the device is active but is idle, which means I'm not really using it to do any network stuff. And the third temperature is I use iPerf3 and I test both upload and download speed at the same time, and then I run the test for 10 minutes. Right before it's ended, in 10 minutes, I will measure the temperature. Let me pick the Mac Pro built-in Ethernet port as example. Now it's active, right? I select it, and then I say make service inactive. Then I take the first temperature. Then I make it active. Take a second temperature. Then I start testing. I measure the third temperature. Okay, this is the 3 different temperatures I take for different device. Let me explain you how exactly I get the temperature. I installed the free stats app for Mac OS, and I use the sensors function to show me the temperature for the Mac. It seems Mac Studio doesn't have a sensor close to the NIC, close to the 100 gigabits part. So for Mac Studio, I didn't take the measure, but I did take down the left fan and the right fan speed showing on the top of the screen, because it does have sensors for the 2 fans, right? And as you know, the noises come from the fans. For the OWC and CalDigit external adapters, the way I measure temperature is pretty simple. I use a thermal gun, scan the surface area of the device, take note of the highest temperature at that time. This is the result. As I explained, there's no measurement for the Mac Studio because it doesn't have sensor. By the way, the unit is in Fahrenheit. I didn't notice difference between inactive and idle. Maybe because I didn't take a long time, because if you leave the external adapters long enough there idling, of course the temperature will be hotter. But anyway, I only had the measurement for the idle moment. As you can see, even when it's idle, the CalDigit is hotter. And after I run the full speed network testing for 10 minutes, they both become much hotter. The delta is almost the same for both of them. During the testing, I also used the thermal gun to scan the Mac Studio. I didn't get any difference before and after. And about the fan speed, the stats, the app didn't show any difference before and after, which means even though the NIC is working in full speed, the fan speed doesn't change at all. Because the speed is the same, of course, I still couldn't hear any fan noises. For the OWC and CalDigit, they don't have fans. They are dead quiet. The last comparison is about the power consumption. The way I measure power consumption is again using the free stats tool. In sensors, the very last item is system total power. Before I start the 10 minutes full speed network testing, I take the number down, and then after it's done, I take another number. This time from inactive to idle mode, I did measure some difference. So that's why I'm showing you 2 different deltas. One is from inactive mode to idle mode. The other one is from idle mode to the full speed busy mode. The total power consumption, just because I was doing the network testing, the power consumption were almost the same. I'm not surprised CalDigit is a little bit higher, because first the speed were higher for CalDigit and the temperature were also higher. So that explains why it consumes more power. This is almost the end of the video. Let me summarize it. As you can see, in real world, they behave almost the same. So now you may ask, what's the point of the testing? What you want to achieve? Basically, there are 2 purposes for my testing. The first thing is because when I purchased my Mac Mini, I didn't get the 10 gigabits upgrade, which cost $100. In my opinion, if now you want to purchase the Mac Mini M1, if you do need 10 gigabits network, just pay the extra 100 because it will be cheaper than you buy extra external adapter, and the performance should be the same. The second purpose of the testing is I want to do some preparation for my next video, which is about what if the 10 gigabits network is not enough, how I can achieve higher speed. If you are interested, check my channel. Okay, thanks for watching.